In this fourth video, let's look at integrals that involve trigonometric functions, where integration by substitution helps us to find the answers. So in this first case, we have cosine of 4 over x all over x squared dx. So we're going to let u equal 4 over x, which we think of as 4 times x to the minus 1 power. So then du will equal minus 4x to the minus 2 dx. Or we can rewrite this as minus 4 over x squared dx. So now let's go over to the original problem. Making our substitution, we have cosine of u, and if we look at what's left, we see 1 over x squared dx. So going over here, we see that 1 over x squared dx, dividing du by negative 4, we can have minus 1/4 du equals 1 over x squared dx. So we can replace 1 over x squared dx with minus 1/4 du. Now we have an integral all in terms of u. So if we pull the minus 1/4 out front, we're talking about the integral of cosine of u du, which is just sine of u plus our constant of integration. And then our last step will be to do a back substitution. So we'll have minus 1/4 times sine of, and instead of u, we have 4 over x plus our constant of integration. For our second example, let's look at one that involves the square root of x along with a trigonometric function. So in this case, since we see a square root of x in the numerator and denominator, we will let u equal the square root of x, which we can also think of as x to the 1/2 power. Then du will equal 1/2 x to the minus 1/2 power dx, which is the same as 1 over 2 times the square root of x dx. Making our substitution here, we will have 10 times sine of u. And if we look at what's remaining, we see that we have a 1 over the square root of x dx remaining, which we can solve for in terms of du. That would be 2 times du equals 1 over the square root of x dx. So now making that substitution, we'll have times 2 du. And let's rewrite this as 20 times the integral of sine of u du, which is something we know from our antiderivatives. The antiderivative of sine of u is negative cosine of u, so we'll have negative 20 cosine of u plus our constant of integration. And finally, doing our back substitution, we'll have minus 20 cosine of the square root of x plus our constant of integration. Our next example involves the integral of two trigonometric functions. So first, since these are combined by addition, let's go ahead and write this as two separate integrals. Let's consider the first integral, which will be 14 times the integral of sine of x dx, and the second integral will be 9 times the integral of tangent of x dx. So now for this first integral here, we know an antiderivative of sine of x, namely negative cosine of x. So this will be 14 negative 14 cosine of x plus the constant of integration. Now for this integral here, we don't know an antiderivative of tangent of x. So instead, let's rewrite this in terms of sine and cosine. So this will be the same as 9 times the integral of sine of x over cosine of x dx. And now we see a function and its derivative in the same term, so we can let u equal cosine of x, and then du will equal negative sine of x dx. So if we make this substitution, we'll have 9 times the integral of 1 over u, and we can replace the sine of x dx with negative du. So now this integral will be negative 9. Well, the integral of 1 over u du is the natural log of the absolute value of u plus a constant of integration. So we'll have, doing our back substitution, negative 9 times the natural log of the absolute value of, in this case, u is cosine of x, plus a constant of integration. And now let's combine this with our earlier result. And so this will be plus a negative 9 natural log of the absolute value of cosine of x plus a constant of integration. And as our final step, let's combine these two constants of integration into a single constant. So we'll have negative 14 cosine of x minus 9, the natural log of the absolute value of cosine of x, plus one single constant of integration. In this next example, we have the integral of a product of two trigonometric functions, namely the sine function and a secant squared function. So in this case, we're going to let u equal cosine of 5x, so that when we take the derivative, we will have a function involving the sine of 5x. So if u equals cosine of 5x, then du will equal negative sine of 5x times, and this is important not to forget because of the chain rule, 5 dx. So making our substitution here, we'll have the integral of, we'll have secant squared of u, and what's remaining is the sine of 5x dx. Well, over here, we can actually rewrite this as du equals negative 5 sine of 5x dx. So sine of 5x dx is equal to minus 1/5 du. If we make this substitution, we'll replace the sine of 5x dx with minus 1/5 du. And now the problem is integrating essentially a secant squared function. Well, the tangent is the antiderivative of secant squared, so this will be negative 1/5 tangent of u plus the constant of integration. And our last step will be to make our back substitution. We will replace u by cosine of 5x, so we'll have minus 1/5 the tangent of the cosine of 5x plus a constant of integration.